Let's continue on in section 1.1. Let's solve a few more equations. If you like, you might try copying down the equations and seeing if you can solve them for yourself right now. In example 2a, we have 3x plus 2x equals 7x plus 5. On the left-hand side, we can combine 3x plus 2x is equal to 5x. Since those are like terms. And then on the right side, we just have 7x plus 5. And then if we want to get the x terms together on the left, we would subtract 7x on both sides. And that will give us minus 2x on the left and 5 on the right. And then if we divide by negative 2, we get to our solution. We get x is equal to negative 5 halves. In example 2b, we can start out the same way. We can add 3x plus 2x to make 5x. But notice now that we have the exact same expression on the left and the right. So we could leave it like this, or we could try to go on and take another step. If we wanted to combine the x's on the left, then we would subtract the 5x on the right so that they cancel on the right. And then the consequence is we'd have a minus 5x on the left as well. And of course they would cancel. And so then we would just be left with 0 equals 0. So now we're not able to go any further. We can't solve for x. We can't have x on the left by itself like we did in the previous example. But we can go ahead and make a conclusion. We can say what the solutions are. Since 0 is always equal to 0, regardless of the value of x, what that means is that any real number is a solution to this equation. Any real number is a solution to this equation. We can write that as, in set notation, as the set of all real numbers. And you may have seen this written before with a capital R with two vertical lines there on the left-hand side of the R, the set of all real numbers. This is a special type of equation called an identity. And when we say it's an identity, what we mean is that it doesn't matter what value we put in for x, we always get a true statement. You could plug in a value for x, whatever number you like, 1, 2, 3, maybe a fraction or a decimal or a negative number, and check, just like we checked solutions in the previous video, and see that we get a true statement. So in number 2b, we have a special type of equation called an identity, where any real number is a solution to the equation. And if we go back to number 2a for just a moment, we saw there was only one number that made the equation true. This type of equation now we'll call a conditional equation. And so that's new vocabulary. We didn't mention that in the previous video, but it's true for all the examples we saw in that video. Those were all conditional equations as well. And now here we have one more. So this is a conditional equation. This equation over here is an identity. There's one more possibility in terms of the number of solutions we could have. We'll see it when we look at the next example. In example C, let's go ahead and start to solve this. Let's combine the 3x plus 2x to make 5x. And then on the other side we have 5x plus 4. So if we go on and try to isolate x on one side, we would subtract 5x from both sides. Again, the x's would cancel on both sides, just like they did in the previous example, except now on the left side we have 0, but on the right side we still have a 4 left over. So this is never true. 0 is never equal to 4. And so what this means is we have arrived at a contradiction. This type of equation is called a contradiction. And what it means is that there is no solution to this equation. And we can write no solution, or we could write the braces with nothing inside, or there's another symbol that means the same thing. It looks like a 0 with a line through it, but it's not the number 0. It's the empty set. It's the empty set, the same as the curly braces with nothing inside. So again, when we saw 0 equals 4, that's never true. That's a contradiction. In part B, we saw 0 is equal to 0. That's always true. That's an identity. Okay, one more, just to keep you on your toes here. In example D, it looks a little bit different. Let's see what happens. Let's do 2x minus 16 on the left side, and then on the right side we have 3x minus 16. When we subtract the 3x from both sides, then that's working okay. 3x's cancel. We're just left with 2x minus 3x is minus x. And then if we want to get the 16, the minus 16 to the other side, we would add 16 to both sides as well. And notice that's going to cancel on the left and also on the right. So what do we write on the right-hand side? Well, if all the terms canceled, we're just left with 0. So we have negative x is equal to 0. We could divide by a negative 1 on both sides, or, well, maybe that's the best way to write it. Then we're clear that the negatives have canceled on the left, and we're just left we just left with an x on the left side, and then 0 divided by any non-zero number is 0. So the solution is x equals 0. And what kind of equation is that? I bet you said it's a conditional equation. Since it has a solution, it has exactly one solution, then it's a conditional equation. Let's see here. Okay, that's enough for this video. There are a couple more equations I want to show you. I'll put them in the next video, and that will wrap up section 1.1.